Hello and welcome to this video. Today we will be talking about Boxplots. Boxplots has an alternative name, the box and whisker display, because as shown below, it consists of two boxes along with two whiskers. In this way, it provides a visual representation of the dispersion of a distribution. Later in the video, we will talk about how Boxplots relates to the dispersion of a distribution, and how it describes a distribution. When we introduced the measures in distributions, we had videos specifically on the topic of center and spread, in which we talked about the mean, the median, as well as the range, the interquartile range, and the variance. Here we are going to incorporate these measures that we learned and relate them to a box plot. So please review those concepts I mentioned above because you must understand them thoroughly before we move on. Generally, a box plot gives one measure of the center, which is the median, and two measures of the spread, which are the range and the interquartile range. But how? Well, the boxes show the spread of the two middle quarters, and the whiskers show the spread of the two outer quarters, meaning that the length of this whisker over here is the range of the first quarter. The length of the small box in the front is the spread of the second quarter. The length of this small box is the spread of the third quarter. And finally, this length here is the fourth quarter. So let's think about this line over here. It is in between the boxes that represent the second and the third quarters. And what separates the second and the third quarters? What divides the distribution into two equal halves? That would be the median. Therefore, we note that since this line is right above the value of 4, the median of this distribution would be 4. Now let's think about the length of the boxes. It spans from the beginning of the second quarter to the end of the third quarter, so it represents the interquartile range, i.e., the range of the middle 50% of the data. The boxes starts at 3 and ends at 6, so the length is 6 minus 3 equals 3. And the interquartile range will be equal to 3 as well. What about the length of the whole box plot? The graph starts at the smallest value and goes all the way to the largest value. So the length of the whole plot is just the range of the distribution. In this case, the box plot is from 2 to 9. So the range is 9 minus 2. Which gives 7. Now that we know how to interpret information from a box plot, let's see how these pieces of information describe a distribution. We can obtain a 5-number summary from a box plot. It includes the median, the extreme values, and the quartiles. These characteristics of a distribution that Boxplot conveys are not immediately available from other types of graphs, like the histograms or the stem and leaf displays. So this is an advantage of Boxplots. Compared to the mean and the variance, the median and the interquartile range are insensitive to outliers. So the 5-number summary gives a useful description of the distribution. Additionally, we can use the interquartile range to mathematically distinguish outliers, so box plots are resistant to outliers. However, note that because of this trait of the 5-number summary, some features like the skewness of a distribution is very hard to identify from box plots. For the same reason, some sets of data can have the same 5-number summary and boxplot, but dramatically different distributions. Let's take these two sets of data for example, and below are their histograms. Please note how different their histograms seems. Now we can try to get our 5-number summary and draw our boxplot. We need to first arrange the data from least to most. And here it is. Now we can construct a summary. This should be fairly easy, because the middle number will beat the median. And the quartiles are the medians of the first and second halves, so -50 and +50 for both sets of data in this case. The smallest and largest values are respectively -100 and +100 for both sets. And here's our summary. The median, the first quartile, the third quartile, the smallest value, and the largest value. With the 5-number summary, we can now construct the box plot for the distributions. Let's first deal with set 1. The median is 0, so let's draw a bar there. We also put bars at -50 and +50, because those are the quartiles. And we can complete the box part. Now let's draw the whiskers. The smallest value is -100, and the +100 is the largest value. Okay, now we finished the box plot for set 1. Set 2 has the same 5-number summary, so it should look the same as set 1. Here it is. Now if you recall the histograms of the sets of data, you'll see how the distributions that are so different can have the same box plot. In summary, today we discussed how a box plot relates to the dispersion of a distribution, and how it describes a distribution. And that's all for today. See you in the next video. Bye.